All right, 2.5 is a very big section. It's very important, and so I've split it into two parts. So we're first going to look at part A, which is interpreting slope of a regression line and the y-intercepts of a regression line. So when the relationship between two quantitative variables is linear, we can use a regression line to model the relationship and make predictions. A regression line is a line that describes how a response variable y changes as an explanatory variable x changes. The regression lines are expressed in this form. Now, this looks a little bit like y equals mx plus b, like you learned in algebra. It is similar, but in statistics we call it y hat. It has that little hat on it, equals a plus bx. Okay, it's the same thing, but we just rearranged these two elements right here. The b, the number with the x, is still the slope, and the a is still the y-intercept. Okay, so it's just a little backwards from what you did in algebra, but it's the same equation. All right, but we use this to represent the relationship between two quantitative variables. So to enter in, you're going to enter data of the explanatory variable into list 1, and then in list 2, you're going to put the response variable data. Okay, you'll press stat, choose calc, and then number 8, linear regression, and choose calculate. All right. Now, this little bottom half, if your calculator doesn't show the r and the r squared values, then here's the steps to do that. So you may need to pause the video and make a note of that. So in the regression line, y hat equals a plus bx. A is the y-intercept, b is the slope. So the y-intercept is the predicted value of y, whatever the response variable is, when x is 0. Whenever the explanatory variable is 0, what would that response variable be? The slope, or b, of a regression line describes the predicted change in the y variable for each 1 unit increase in the x variable. Okay, it's kind of wordy, but you'll get used to that. Now, it's very important to include the word predicted or its equivalent in the interpretation of the slope and the y-intercept, because these lines are not perfect. This line is just a predictor. It's not exactly right all the time. Okay, so we don't think they're exactly right, so we have to include the word predicted. So let's look at how do we interpret. Interpretation of slope. For every 1 unit increase of the explanatory variable, we predict that and then you plug in what the response variable is, then you choose increase or decrease based on the sign of the slope, and then the slope value and the appropriate units. Okay, now that's very technical, and I'll give you several examples of this, but the red words are the words you're going to use every time. You're going to use different words, obviously, for explanatory variable and units for explanatory variable, and same with the response variable. That's going to depend on the problem. And the increase and decrease of slope, that is all dependent on the value of the slope. Now, to interpret the y-intercept, here's the structure you're going to use every time. When the explanatory variable, and don't say explanatory variable, say whatever it is in context. When the blank is 0, we predict that the blank will be blank blank, whatever it is. Okay? So what I put in parentheses, you're going to plug in with the actual value in the context of the problem. Don't just say explanatory response variable. That would be counted wrong. All right, now, you have to stop and think about if this is possible, the y-intercept thing. Okay? If not, the y-intercept does not have value in the problem. For example, if when the square footage of a home is 0, the price of the home is a negative 2,000 based on our equation. Well, stop and think. Does that make sense? It doesn't make sense. A home is not worth a negative amount, even if it's blank. There's not a home there. That's still land. It has value, so it's not going to be a negative value. So that doesn't make sense. Sometimes the y-intercept will not have any logical value. So you just have to think about that. Okay? So let's try an example of this. So the scatter plot shows the relationship between the number of slices of pizza eaten by each member of a football team, which is x, the number of laps around the block the player could run immediately after, which is y. So x is the number of pizza slices. That's the explanatory. The response is the number of laps that they can run around the block. All right? The equation of the regression line shown is, and there it is, and really that y should have a hat on it. So nice way to type that in. So y hat equals 10 minus 0.67x. So remember, this number right here, the negative 0.67x, that is the slope. This is the y-intercept. All right, so A says interpret the slope of the regression line. So we have to interpret this. So if you need to go back and look at your notes, look at the structure, but I'm going to write it in the context of the problem. And so what is the unit of our x value? It's slices, right? So for each additional slice of pizza eaten, a member of the football team is predicted to run 0.67 fewer laps. Okay? For each additional slice of pizza they eat, a member of the football team is predicted to run 0.67 fewer laps. Now you can word it differently, but you have to use the same units. Slice of pizza versus laps in the right context. But you could have written it differently if you want. But notice I use the word fewer. That's an indicator that it's a negative. If it had been positive, I could say 0.67 more laps, right? So that's how you would interpret slope in this problem. Now B says interpret the y-intercept. And does it make sense? So let's look at this. If the y-intercept is when x is 0, so let's think x equals the number of slices eaten. So at no slices eaten, how many laps do they predict they can run? Well, if this whole part of the equation back here is 0, then we predicted they can run 10 laps, right? So that's legit. That could make sense. All right, so let's interpret it first, okay? When a player has not eaten any pizza, we predict they could run 10 laps. Okay, does this make sense? Yes. This makes sense. That's all you have to say. Sense because 10 laps is plausible. Meaning it's logical. It could happen, all right? So if it wasn't plausible, you'd have to tell me why it's not plausible, okay? But you're going to have a lot of practice with this with the worksheet today. So hopefully that makes some sense, and we'll do some more examples in class.